Well, welcome back. In the last video I told you I would be removing this Aerovox 0.0005 microfarad capacitor and cleaning it up, and it needs it pretty bad. I'm glad I decided to do it. Let's get a little focus on a close-up here. Look at the back, look at the blob of solder they put on that thing. Come on, baby, focus in a little better. Maybe I'm a little too close. We're going to have to remove all that solder right there. Plus down in here where it was soldered to the tube pin also has to be extracted. You got to get that out of there. Too much solder, way too much. I don't know why they did it. I guess of course they use those great big giant irons. They don't have, in 1931, they didn't have what we have nowadays, you know, small little soldering irons and things like that. They had these big, like, you know, 100-watt irons suspended from the ceiling, and these girls would sit there, mostly women, because they could handle the wires better. Not all were women, but many of them. They could handle the wires, and they were just better at it. That sort of work, from what I understand. Anyway, that whole thing's going to have to be extracted off there, and that's what I'm going to do, and I'm going to do it with my Hacko extractor gun, my FR300. Alright. Well, the resistor is out, and here's that second wire that I mentioned in the last video. I don't know, you know, it's possible that they didn't put two wires in to connect the two together. It's possible that, I don't know, it's possible somebody changed that resistor out and they just clipped it off and left the old lead in there. Doesn't matter, who cares? You know, the point is it's out of there now. And I have cleaned up the end of the capacitor fairly decently. I'm going to go ahead and hit it with alcohol. We're going to make it look a whole lot better. And we're getting ready to extract this solder right here. So let's go ahead and focus in on it and see if I can give you all a demo on this Hacko solder extractor. Let me see. I guess I better do something first though, huh? Yes, we have to do the preparatory work. We got to get these wires out of the way. We got enough wire damage in this thing, enough problems as it is. We don't need to create any more, okay? We go slow. We take our time. Now I'm going to try to extract that glob of solder off of that baby right there. Let's see what happens. Well, she's just about gone. How about that, huh? How about them apples? Looks like that's about it. I do believe we got it. All right, well, I'll do a little more touch-up work with it, give it a good cleaning, and then we'll get the old capacitor mounted back up in here the way it's supposed to be. I think it went around like this somehow. We'll figure it out. I guess it went like this. That's the way it went, like that. And then we'll go ahead and get it mounted back in. She'll look really good. Well, there we go, folks. Everything is nice and clean, looking real good and shiny. All the excess solder has been removed front and back. I cleaned it with alcohol really good. So now all I have to do is connect up this capacitor back into the hole. And then I have to take my 150k ohm 1-watt resistor that I was lucky enough to find in my stash. I can't believe it. And I'll run it through that hole, bend it around the back, and run it down through the connector on the bottom of the tube socket. And I'll put some Teflon, what we call spaghetti insulation on here. I'll show you that stuff for those of you who may have never seen it. Here's something I bought on eBay many years ago. It's called Teflon tubing, and it's used, you slide it over the leads of resistors and capacitors to insulate them. And we always called it spaghetti tubing. And the reason we call it spaghetti tubing is because it looks like spaghetti, okay? Now here are the diameters. I believe this is in thousandths. 0.062 thousandths is the outside diameter of this stuff. And the hole down through the center is 0.031. Now this does not come up on eBay very often, but when I saw it, I went ahead and bought a roll. I should have probably bought 2 rolls, but I never thought I'd get involved in radio this heavily. I had no thoughts of ever, you know, putting out YouTube videos or buying a ton of radios where I had to use this stuff all the time. I figured I'd buy some of it, and this thing was full when I started. It's the same thing I've already used right here on this capacitor, this black stuff here and here, except that this is Teflon and it's clear. So let's go ahead and cut it, and to the length I need. Yeah, this is the kind of stuff you have to use very sparingly, you know. I'll go ahead and cut it to the length I need, and we'll get this resistor mounted up in here next to this capacitor. Well, there she is. Run through this loop, run through a hole in this connector, or this terminal on the bottom of the socket, and then I kind of bent a little, just a little hook in it to hold it in place. Now we'll go ahead and solder it up. All done. Now doesn't that look a whole lot better? Yes, it does. Nice and neat, not globs of solder and flux all over the place. And I've got my insulation, my my spaghetti tubing on there. And we're just going to let this resistor hang for right now because we're not to the point where we need to hook up the other end. Before we go any further, I want to pass on some information to you. Another one of my famous lectures. John's lectures. Oh boy, another lecture. When you're working, you newbie types, the folks that have just entered the hobby or just need a refresher or never did get into it that deeply and now you're coming back, whatever the case may be, don't be afraid to make changes. Let's say I put this capacitor in and then, 90% through the restoration I realize, I do not like the way that capacitor was done when I first put it in. Well, don't leave it like that. Fix it the way you think it should be. Don't be afraid to change your mind. There's really no set way on how to do anything with these old radios. Except, if you can, keep your wires close to the chassis. It prevents hum, okay? Keep them as close to the chassis as you can. Other than that, your solder joints should be good. They should be reasonably, attractive when you're done, shiny and that sort of thing. They don't have to be perfect. Don't worry about it if they're not perfect. Just make sure you have good mechanical connections and good solder joints the best you can, all right? Don't be afraid to change your mind. Don't be afraid to look at something the way it was done at the factory and say, we can do that differently today. I mean, this is 2016. We can make a change here and make that better. The way that wire was run, let's say the wire was run underneath this thing. Well, maybe it would be better if we ran it up over the top and down, okay? As long as it stayed close to the chassis. You can make those kinds of decisions. It's your radio. You can make those changes as you see fit. Just don't go radical on it. If you go radical, and then you're probably going to have some problems, and then you're going to have to go back and change everything back the way it was. Now let me tell you what we're going to do with this thing. After I get everything done here, everything wired up, all the components put in, then we're going to go back and look at every single wire. And if I don't like a wire, if I don't like the way it looks, like this one right here, this one kind of sucks. That one there, I don't like that one at all. They tapped into it right there. They just stripped off the insulation. That may not have been done at the factory, I don't know, but that wire is coming out, that's for sure. We are going to remove and replace any and all wires that don't look good. And, sometimes I get folks that say, well, why didn't you change that wire? Why didn't you change that? It's not time. It's not time. There will be no wine before it's time. All right, let's finish this video up real quick like if we can. We've checked out all the resistors around this area to include, this one down here and this one here. But we still have one more to go right there. That is R3 it looks like. And again, it's a 40,000 ohm resistor. Now I don't have 40s, but I do have 39s. Now this is the resistor we want to put right there. Yes, we do. So the question is, where is that little booger? According to our handy dandy little schematic, pin 4, again of the second detector, should have a resistor connected to it. That's the one we're looking at. The other end of the resistor should go up into the bottom of the T3 secondary. Don't worry about this capacitor or this coil or this capacitor. Those three boogers are all inside this can. Just pretend that those green things are not there, okay? We're just concentrating on this resistor. One thing at a time. That's what it's all about. So let's find out if there's a resistor coming off of pin 4 and going across through the resistor and up to the bottom of the T3 secondary. Let's find out. Well, there's our 24, our second detector again, right here. Now we're looking for pin 4. 1, 2, 3, 4. Sure enough, look at there. Let me get this light out of the way. It's a little bit too bright, I think. There it is right there. We have a resistor coming off of pin 4. Right there. Now, according to the schematic, there's supposed to be a wire from the opposite side of the resistor going up into the T3 secondary. Well, this is the one side where it's soldered to the terminal on the socket. Let's go to the other side. What's on the other side? Well, we've got a glob of solder again, and we also have, looks like a wire has been cut off right there, and we also have a wire going back this way. Where does that wire go? Well, shucks. Look where it's going up in there. It is going, where is that wire going? It's going, I'll get this thing out of the way here. It's right in our way where we can't see anything. This is the wire we're looking at right here. And look where it's going, up inside the T3 transformer. Right there. I think I labeled this thing T3. If I can, yeah, can you see it down there? It's a little difficult. Anyway, I wrote T3 right down in there. Let me see. See it? Yes, it is. I don't lie. Anyway, so this is the resistor we're looking for, and that is the wire that goes up into the T3 secondary. But you know, you can't stop there. And I'll tell you why. Just because the wire is going up into the T3 secondary doesn't mean it's going through this coil here and coming out the grid cap connector of the 24 tube. It could just be laying up in there connected to something else. I don't know. So what we need to do is go ahead and check for continuity from the grid cap on the tube down through the coil down to this resistor and make sure that that is in fact the proper connection. So let me set up the multimeter. I have the black wire from my multimeter connected to the grid cap coming out of this can right here, which is T3. And we're about to touch. Let me get my whole multimeter over here so everybody's in sync. Let me set it up on 200 ohms. That's the smallest setting. We're not looking for anything above 200 ohms here. If I get my meter lead straight, give me a second here. Give me a second. Okay, there we go. Now all I need to do is touch right here where it comes out. And we should have continuity if that wire right there is the correct wire going up into that can, okay? Here we go. Touch. There it is. There it is, ladies and gentlemen. The correct wire going up into that grid cap connector. That's good. So all we have to do is change out this resistor and then figure out what we're going to do with this mess at the other end. Now, as I said, there is a wire stick. Well, that's a really bad solder joint right there. Don't ever do stuff like that, guys. It looks like they heated the solder and let it drip on the wire. What is this wire right here? You know, why is that wire sticking out? We know this is right. We know we got to change this resistor. It gets connected up there. And we know this wire is right going up into the can. What is this thing? Well, I don't know. Let's go back to our schematic, see if we can figure it out. That little wire stub, you know, comes from the coil of the secondary, and this side of the resistor comes down this side. Right in here is where our stub is. This little part right there. It's right there, that little stub. Let's follow it down. Well, obviously it connects to one side of this capacitor inside that can. Let's follow it down a little further. The connect comes all the way down, and it connects. It looks like one end of our canned ohm resistor where our 680 ohm resistor is right here. I'll bet that's where that thing was originally connected, okay? Well, we're not going to connect that right now. We're going to go up here and change out this resistor and try to dress up this wire setup right here where that glob of solder is. I'm not exactly certain how I'm going to do that. I may. You know, it's pretty close down here to this terminal strip, and we have a lot of terminals that we're not going to be using. You know, we're going to mount these resistors here. We're going to have a lot of leftover terminals. I may decide to just go ahead and use one as a junction point for all of this wiring. Why waste a good terminal, right? That was one of the reasons I bought this terminal strip and cut it in half, because I knew I'd have plenty of connections. It beats putting, terminal strips all over the inside of the bottom of your chassis. Hey, you could do that. It wouldn't be any big deal. There's plenty of screws in places we could hook them up. There's a right there, right there. They're all over. I could even connect one right there. I could connect one right there. All over the place. Anyway, let me go ahead and skull brain that. The next time you see this chassis in our next video, I will have changed that resistor out right there with this 39K, and I should have a solution as to exactly how I want to do it. But right now I'm almost 100% certain it's going to be one of these terminals on the outside, not on the inside, on the outside. But you never know. The point is, I don't want to drape a wire across these hot resistors. Okay, I don't want to get them very close. I want to be able to run it down, maybe bring it up through the center and connect it to one of these. I don't know. Maybe run it all the way up and just connect it directly below where the resistor was, somewhere in here. I'll figure it out. Anyway, until next time, this is John.